Hi. Fourth is fun. Being fun is being creative, and being creative is being productive. So what we've got here today is a Raspberry Pi Pico with an RP 2040 chip on it, on a board, which also has a WS2812 RGB Neopixel LED. Also has audio and a little buzzer on board, a piezo transducer actually, and over here a little micro SD card. So we have serial comms hooked up over here that we got connected up to a terminal up here, but no power at the moment. And we're going to fire this up with MiCrisp 4th and some of my own routines on it. So let's plug it in, see what happens. Well, that's good. We had a beep out of it, and the Neopixel went red, then green. This is very good. And we also have a prompt. It tells us down the bottom here that we have 3.9 volts coming in, and it's 23.6 degrees Celsius. All right, and also the card too, don't forget, it's detected the card and mounted that. Let's have a look at the card then. Let's do a directory then. So we have a few files on there. Let's move that up a little bit so we can see what's going on with the camera and everything else. Do this again. DIR. Let's do even better. Move up a bit more. Keep this all on camera. DIR plus. And that will also read the file header contents and spit them out for us over the right here. Okay, so we can see that tiger.gif is GIF89A, or GIF89. So let's proceed with playing with this a little bit. We can turn LEDs on and off. Up here in the top left, over here we have LED. Just got a pointer over here. We have LEDs connected up to 0, 1, 2, 3, 4, 5, etc. At the moment, 0 and 1 are lit up because they're on serial comms. That must mean that 2, if I turn that on high, let's just turn it on 2 high. There it is. 3 high. Very good. And so we can say, I think I've got something in here where we can flash the LEDs very easy. Flashes. We have something in there called flashes. We can put a count in there and which LED we want. So we'll say for 3 flashes on 3 flashes. Let's have a little look. Yep, 3 quick flashes. Just used as a little indicator and as a demonstration. We also have the Neopixel, and this is in here somewhere. We'll have a little look where we define a Neo pin, which is normally 28 for this particular board. And then, by the way, this is can't remember which one. It's like a RPi Pi board. It says down here, RPi Pico board. Okay. Now, what we're going to do is also try the Neopixels. It's already set up for the correct output, and so all we're going to do now is write either an RGB code to it. Let's try an RGB code to it. So a 0 should turn it off. Let's try that out. Turned it off. It's green, red and blue. So therefore, if I put in 20 Neo store, we get a blue. If it was a 2000, that should be the red. Let's try that out. And 200000 is the green, and of course we can mix them up and get any colors. What we can also do, we can write to an array of Neopixels. In this case we only have the one, so we can write to it from a buffer, and we have a couple of quick words here. White, let's make it white. I think it's going to be pretty bright. Yep, a bit bright. Let's blank that one. Blank it. Now we can also make it blue to a certain degree, or red or green. Let's try the green in 20 green out of 255. 20 green and 100 red, etc. They're just a couple of quick ones, and of course we can mix this all around and we can put in something like 10, A0, 00, Neo store. Get different colors out of it, which we can't see on here, so I'll drop that down. Okay, So you can see that it's still a bit white on the video here by the look of it. Anyway, the main thing is that we're going to have a look at the sound effects. That's all I really set this up to do. We have a little buzzer on board here, a little piezo transducer, and it's hooked up to, let's find it. I've defined it in here, and the buzzer is, I have to fix this up a little bit, but it's on 18, and I've got it in the wrong place at the moment, so I'll have to bring that back again. Now, that's in the source code, that is. I've patched it. So what we're going to do is produce tones. We can do a beep up here. Let's try a beep. Let's move that up a bit so we can see the code. Do a beep, or 3 beeps. Very simple. We just pass the frequency in hertz and the duration in milliseconds to tone. So that means that if we try something like 200 hertz for half a second, this is what it should sound like. That's about right. And this might be a bit high for the little transducer, but let's try that out as well, 200 milliseconds. Okay, that does work. Don't think you'll hear this. I heard a click. That's me. So we have a few other sound effects in here. Look at siren. Siren is a bit more complicated. It takes 2 frequencies, 400 and 550, and has a duration of 400 milliseconds that it passes through to warble, which will alternate between these 2 tones. So what we're going to do is try that out. Siren. That's really hard to do, isn't it? And what about ring? Ring. Here it is. Better answer that phone. And it's still ringing. Now let's combine a few of these together. We've got a few other ones in here called zap and saucer. What I'm going to do is I'm just going to copy this comment here and copy that, paste it into the terminal here and hit the enter. See what happens. Right, better ring for help. There we go. Oh, siren's already there, isn't it? So what happened? Well, zap was very easy. It was a bit more complicated. Just went through a little loop and generated a tone and etc. So it gave a zap sound. So we can try that one again. Zap. Sounded like a little zap, didn't it? And a saucer or UFO, well, we can see it's alternating between a couple of tones there as well, a bit like a warble in a way. So we did that a few times, and that made it very easy to generate sound effects. We can combine those together as we have done in here in various ways to generate new sound effects on top of that as well. It's up to you. I mean, I'll just do a quick one here. I'll just get it to read from memory, starting from 0, that's the ROM, read through, basically duplicate that address of 0 that I left there, fetch that, make that our tone, and what we're going to do is also fetch the next one, location, and use that as a duration. All right, and then we'll pass that through to tone, and then let's just step up 2 at a time. Add 2 to that address, keep on going until I hit any key. How does that sound? It looks about right. Let's try it out. Could be anything. It's thinking. This is machine code. Can you decode it? Yeah, it could generate anything. It could even play bark. Single voice. Hit the key and stop it. Very good. What else can I show you? There's lots of different things I could show you, but that was just very quick. I just showed you very quickly the file, the micro SD as well, didn't I? And of course we can open files and look at them and everything else like that. We can even dump them out, by the way. Let's do a wide listing of that again. I'll do it this way. Let's open up back here. We've got a wave directory, text directory I'm going to go into. I'm going to open that up, text. Let's have a look in there. All right, War of the World, War and Peace, here, War and Peace. Let's open up, fopen, War Peace. We keep to 8.3 names, otherwise it's all over the place, too long. War Peace, that's been opened, knows where the sector is. We can even treat it as virtual memory. Let's dump out the first 128 bytes of it from the SD card, dump that from the open file. There it is. That's the start of it there. And if I want to, I can just sit there and typing that out. Very easy to do. I can say if I want to get this character here at 60, it's very easy. 60 stc fetch, and what is it? Well, let's print it out as a byte. There it is, 65. Very easy to manipulate the files, copy them, do anything you like with them, treat them as individual virtual 4 GB memories, up to 4 GB. Okay, that was a bit of fun. It was fun for me, and if you do the same yourself, it's even more fun. All right, thank you.